Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 8 from the October-November 2016 Pure Mathematics P1. This is from Cambridge 9709, and this is the variant 1, paper 1, variant 1. Okay, 1-1. And this question here is also question 13 from the textbook from Pemberton of Cambridge P1, page 96, the cross-topic review, exercise 1. And this question has been asked by one of my students for me to answer. And it's all about functions and range and composite functions, inverse functions, and so on. So here we're told the functions f and g are defined by f of x equals 4 over x minus 2 for x is greater than 0, and g of x equals 4 over 5x plus 2 for x is greater than or equal to 0. And we're told to find and simplify an expression for f of g of x and state the range of f of g. Okay, so we have to find the composite function first, f of g of x. Now, for most people, finding the composite function part is pretty straightforward. Okay, so let's just do that first. We have f of g of x. Okay, so what that means is basically that the function g of x goes into the function f of x. So you can say that the inner function is g of x, okay, and it has to be substituted into the function f of x. So wherever g of x is, takes the place of x in the function f of x. So you can think of this as you're going to have 4 over g of x, 4 over g of x, okay, minus 2. So this x here, this x over here, it's been replaced by g of x. Now what is g of x? Well, g of x is 4 over 5x plus 2. All of this is g of x. So what we've got to do is we've got to take g of x, which is 4 over 5x plus 2, and we've got to put it in place of the x here. So this instead of this, we're going to write 4 divided by 5x plus 2. And then all of that we've got to take 2 away from. So we've basically taken the whole of this function and put it over there. That's what we've done. Okay, so now this looks a bit weird in terms of simplifying it. So I'm going to write it in a way that's a bit more easy to deal with. So I'll think of this as 4 divided by, and I'll have 4 over 5x plus 2. And then take away 2. That makes it a bit easier to deal with. This is like 4 multiplied by 5x plus 2 over 4. Take away 2. 4's cancel out. So you've got 5x plus 2, take away 2, which is equal to 5x. So we can say f of g of x, therefore, f of g of x is equal to 5x. All right, so we've found the algebraic expression for f of g of x, and now they asked us to state the range of f of g. They want us to find the range of this function. Okay, so I'm going to use this video as a way of explaining this topic in a bit more detail. Okay, this is a topic that needs a bit of detail to explain it properly. Now, this questions are only worth 3 marks, right? And to find the range of this function, okay, you know, a lot of students have difficulty with this problem, with this particular situation. So I'm going to take a bit of time to explain it in some detail. So don't think of this as like how long you're supposed to spend doing this question in the exam. Think of this of you know, me explaining to you the basics of the topic, right? So once you understand the basics of the topic, you'll be able to get through this very quickly. But I'm just showing you how we should try to understand or approach such a question. Now, there's 2 ways you can approach this question. Okay, one of the ways you can approach this question is as follows, in terms of thinking about, if you think about what this function is, you've got x, which goes into the function g. Okay, so that's the x goes into g, all right? And then what comes out of g goes into f. And then what comes out of f is the output, f of g of x. Okay, so what is it that can go inside of g? Now, what can go inside of g is defined by its domain. Now, its domain has some restriction to it, apart from the natural kind of restriction, which would be whatever value of x makes this denominator undefined. Okay, so this is a reciprocal function. You can see it's going to have asymptotes. When x is minus 2 over 5, this will be undefined. But this has some further restriction. X is greater than or equal to 0. So what can go into function g are only values of x which are greater than or equal to 0. Okay, that's a condition for g. And then what comes out of g, of course, is determined by this. Okay, because what can come out of it depends on what can go inside of it. So what can now go inside function f after it's gone into function g, okay, depends on what's the output of function g. So we're going to think about the output or the range of function g. Okay, so what I'm going to do is I'm going to think about how to how to find the range of function g first. And now function g, as we can see, is a reciprocal function. Okay, it's a reciprocal function, which means it has asymptotes. X is in the denominator, so it's going to have asymptotes. Now, the asymptotes for this function are, as I mentioned just now, are the values of x that make the denominator 0. So 5x plus 2 cannot be 0, otherwise it will be undefined. So that means x cannot be, if you solve this, negative 2/5. So that's one asymptote. I'm just thinking about this as if it's not got any other restrictions apart from this first, and then I will draw it accordingly. So first you have this is minus x equals minus 2/5 is one asymptote, and the other asymptote is when y equals 0. This whole thing will be undefined, because if it's 0 here, you try to solve it, you'll end up with 0 equals 4, which is undefined. So we can say that there's another asymptote, which is the x-axis, or y equals 0. Okay, so there's your y-axis, there's your x-axis. Y equals 0 is an asymptote, so is x equals minus 2/5. Now, how do we draw this graph? Well, let's try and figure out where it crosses the y-axis. It's going to definitely cross the y-axis. So it crosses the y-axis when x equals 0. When x equals 0, we can say y equals 4 over 0 plus 2, which is 2. So it's going to go through 0, 2. So it's going to look something like this. Asymptote on that axis and that axis. And the other part of it will go on this side. Okay, and we'll continue going down. But this function, according to our restriction that we have here, is for when x is greater than or equal to 0. So it's going to start at this point here when x equals 0. What color did I make that? Okay, it's going to start at this point here. Oops, it's too thick. Okay, over here. So I'll put that closed circle, and it's going to be for the domain x is greater than 0. So all these values of x, it's going to go like this. It's going to go like this, and all these other parts of it have to be removed because they're not in its domain. So it won't have any outputs out here at all. So the output or the range of this function is very small. It's limited between the values of y between these values here. Okay, let me make that a bit thicker. Straighter. Okay, so its range is basically between 2 and 0. Okay, so that's its range. So that's the range, not of the whole function. That's the range of g of x. Okay, according to the condition that's imposed upon it. So g of x can only exist, okay, for values of y which are greater than 0, but up to and including 2. That's the output of g of x. Okay, that's the output of g of x. So you can say g of x, its output is between 0 and 2. Okay, so that becomes the input of function f, because g goes into f. So what comes out of g goes into f. So the values of g that can go into f are only the values between 0 and 2. So that now becomes the domain of the function f for the composite function f of g of x, because g of x has to go into f. So what I'm going to do now is I'm going to make a drawing now of function f. Okay, now function f is this function here, 4 over x minus 2. Now this has an asymptote when x is 0. X can't be 0. Why? Because this will be undefined when x is 0. Okay, so let me just draw these in line so it's like a bit clearer. So now we'll have an asymptote here at x equals 0, which will be this asymptote over there. And it also has an asymptote Did I not draw that very straight or something? Okay, you'll have another asymptote when y equals -2. So that will be another asymptote over here. Now, some of you might ask, why is the asymptote y equals -2? You can think about it as this is a translation of the graph 1 over x. So first of all, it has been stretched by a factor of 4, which doesn't affect the asymptote because you multiply 0 by 4 and it stays 0. But then the asymptote is shifted down 2 spaces. So the asymptote that was y equals 0 goes to y equals -2. Or you can think about it as if you replace the y with a -2 and you try to solve this, you'll end up with -2 plus 2 is 0. So you have 0 equals 4 over x. You try to solve 0 equals 4 over x. The x will disappear. It will be undefined. So you can think about it in 2 ways like that. Anyway, no, that's basically why the asymptote is y equals -2. So this graph will cross the x-axis somewhere. Where does it cross the x-axis? Well, it crosses the x-axis when y is 0. So when y is 0, you'll have 0 equals 4 over x minus 2. So 2 equals 4 over x. So x equals 2. So it's going to cross at somewhere over here. So I'll draw the graph. So that's going to be x equals 2. And the other part of it will be on this side here. So you have x equals 0, y equals -2, the x-axis, the y-axis. Okay, so now the input of our graph here, I mean, I've just drawn it generally, but we can, the domain of this, this is f of x now, and this is y equals g of x. The domain of y equals f of x, okay, when it is, when g of x has gone into it, is going to be the output of g of x. Now, the output of g of x is between 0 and 2. That means what goes into f of x, the domain of f of x in the composite function f of g of x is going to be the values of x between 0 and 2. So that means I've got to get rid of, that includes 2. So I've got to get rid of everything else. So let me draw the part that we need, which is from 2, including 2, x equals 2, and all the way to 0. Okay, and everything else, when x is less than 0, x equals 0, x is greater than 2, all these have gone. So now what we've got left here is, if we look at this here, this is now the range of the composite function. Okay, it's going to go on forever up there. All right, and let me just do it properly. So we're going to have start from there, go up forever. Okay, this one I'll do it again so it's clearer. This is going to be start from there. Oh, it's going to be like this, but that has to be an open circle on that side. So I'll just do this to make it like a bit clearer. On this side, it's going to be an open circle, right? So that's how it looks there. So this is going to be here a closed circle, and they're going up forever, right? Because you can see that, the output can equal 0. Okay, output can equal 0 when x equals 2, because x can equal 2, and the output will go on forever. So we can say that the range, I've got it on white, that's not very good, is it? So we can say therefore the range of f of g of x is y is greater than or equal to 0. Okay, we can write it like that. But we don't write the range as f of x, we write the range as g of x. The domain is we don't write the domain as x is greater than, the range as x is greater than. We don't use x for the range, we use x for the domain. We use y, or we call the function its actual name. So you could write this as f of g of x is greater than or equal to 0, or y is greater than or equal to 0, but not x, not for range, that's only for domain. Okay, so that's how we can figure out the range of the composite function. That's one way of doing it. Okay, so that's one way. There's another way of doing it, which is by considering the domain of the whole composite function. Here what we've done is we've considered the domain of the outer function given the inner function. So we've said the inner function goes into the outer function, and with that, the output of the inner function we then see what will be the output of the of the outer function given that input. That's what we've done here, right? Alternatively, what we could have done is we could have considered the domain of f of g of x. We could have started off by considering the domain of f of g of x. So we can start off with the same thing here. So I'm going to just move this down here. And we can start by considering, let me just move this up a bit. Why is it not moving? Better? Okay. So we can start off by thinking about the domain, okay, of f of g of x. What's the domain of this whole composite function? And then from that, we can then sketch this graph given that domain. So the domain of f of g of x has to satisfy some conditions. The domain of f of g of x has to satisfy the condition, first of all, okay, that we know that what goes into g of x, because we see x goes into g of x, and then that goes into f of x. So first of all, what goes into g of x has to satisfy this condition where x is greater than or equal to 0. And then what goes into f of x has to, the x value that goes into f of x, it has to be such that the output of g of x must be greater than 0. The output of g of x must be greater than 0 because inside f of x, only numbers, x values which are greater than 0 can go in. So I need to, the domain of f of g of x is going to be what satisfies both of these conditions. Satisfies a condition for g of x and it satisfies a condition for f of x. So what goes into g of x has to be greater than or equal to 0. What goes into f of x has to be greater than 0. And what's going to the f of x? G of x. So it has to satisfy this condition. And it also has to satisfy this condition. Now, this condition is where 4 over 5x plus 2 is greater than 0. Okay, so I need to solve this to find the values of x which satisfy this condition. And those values of x will be the condition for what can go into f of x. Okay, what x values can go into g of x such that its output will be acceptable to f of x. Okay, so now this is a bit of a difficult one to solve because if you try to solve it algebraically, you've got this if you try to say, let's see what it equals 0, well, it doesn't equal 0. So you can't find out where it equals 0. So you have to think about either the sketch of this graph, which we already sketched before, okay, or we can think about just logically this particular statement. So I'll first think about the logical way of doing it. It's quite easy. Basically, we know that the 4 is positive. If you divide it by something and you have to end up with a positive answer, then the denominator must also be positive because positive divided by positive will give us positive. If this said less than 0, then we'll say 5x plus 2 must be less than 0. So we can say when 5x plus 2 is positive, means greater than 0, this whole thing, this inequality will be true. If it was less than 0, then it would be false. So therefore we can say x is greater than minus 2/5. So this is the condition, okay, from this part. And this is a condition from that. Okay, so the domain is going to be what is common between these two. The domain is what's going to be common between these two. So the domain of f of g of x is common between these two conditions here. And we can see what's common between them is this. Because if we were to draw like an inequality line, let me do it with if we were to draw a number line, okay, and we had 0 over here, and we had negative 2/5 over here, okay, and we were to draw the inequalities, okay, x is greater than or equal to 0 will look something like this, and x is greater than 2/5 would look something like this, except that would be like an open circle. So let me just, that would be like an open circle over here, okay. So we can see that they are, they are basically overlapping. Okay, they're overlapping from this region here onwards. That's where they start overlapping. So what's common to both of them is basically when x is greater than or equal to 0. Okay, from that point onwards. So x is greater than or equal to 0. So that is the domain of our function. So f of g of x, its domain is x is greater than or equal to 0. So therefore, what's its range? So this is equal to 5x. So the range of this function with this domain, well, we can make a very simple sketch. It's quite easy to sketch that. Okay, so we have our y-axis, we have our x-axis. Okay, all right. If we were to draw this y equals 5x, it would look something like this. If we draw it unconditional or unrestrained, it will just be like going through the origin, and it will, go up forever, y equals 5x. But this is limited to the domain which we just worked out, which is x is greater than or equal to 0. So we can see that this is going to start from this point over here. Okay, in which case this has to be like a closed circle there, right? So it's going to start from here, and you can see the range is, therefore it's going to be going up, okay, forever. So it's going to be something like this. The range will be all y values, okay, which are greater than or equal to 0. So we can say, therefore, the range of f of g of x is y is greater than or equal to 0, or if you want to say f g of x is greater than or equal to 0. So that's the answer to that question. So 2 ways of getting the answer. I hope you understood both those ways. Okay. So whichever way you prefer is fine. This is a good for us in terms of trying to work out what the domain is for a composite function. And here you can work out the range by thinking about the output of the inner function, and that's what goes into the outer function. So the outer function, its range depends on what came into it from the inner function. Okay, so that's the answer to that question. Also, sometimes they do ask you explain why the function f of g of x does not exist, for example, if it could not exist. Okay, and that's like basically if the range of the inner function cannot fit into the domain of the outer function. Okay, if the output of the inner function is not completely contained within the domain of the inner function, okay, then that function cannot exist. Okay, so in this case we can see that the output of the inner function, okay, the output of the inner function in this case is going to be, as we said, is x values which are greater than 0 and less than or equal to 2. Okay, and the input of the inner function are x values which are greater than 0. Okay, so you see over here, we need to look at it from here. This has to completely fit. Let me look at it like this. Let me change the color. This has to be completely able to fit inside the input of the inner function. Now the inner function, okay, so the main function. So this is what can go into f of g of x, and this is what can come out of g of x. So this has to fit completely inside this, and it does. Okay, this is a part of that. So the output of g of x, I'll write it over here. Okay, we can say g of x, its output was basically this. Okay, as we saw here. Okay, so this has to completely fit within this, and this have to match. This has to completely fit within this. The output of the inner function, must fit completely into the input of the outer function, and it does, because x is greater than 0 includes all of these values. There's nothing here that's not including those values there. Okay, so therefore we can say that this function exists. If there was a function where that didn't, if there were any values in here which don't belong here, okay, anything that comes out of the inner function that does not fit in the outer function, that's when we will say that the inverse does not exist. Okay, that's when we say the inverse does not exist. Sorry, not the inverse, the composite function does not exist. Okay, the composite function does not exist if that's the case. In this case, of course, it exists because they've told us to find it and to express and state the range of it. But sometimes they do ask us They say, what, explain why it doesn't exist. So that would be the reason where the output of the inner function doesn't fit into the input of the outer function. All right, so there's part one done. I know it took a bit of time to explain that, but I want to make sure that everyone understands this particular topic. Now for part two, it's to do with inverse functions. So it says here, the functions f and g are defined by f of x equals 4 over x minus 2 for x is greater than 0. Okay, so it's the same two functions, basically. Okay, so they're asking us to find an expression for the inverse of g of x and find the domain of it. So we don't have to worry now about this function here. So I'll just get rid of that for now, just so that keeps that out of our mind. All right, and we have to think about now function g of x. So it says find an expression for the inverse of g of x and then find the domain of the inverse of g of x. Okay, so now the expression for the inverse function, again, y equals 4 over 5x plus 2. And then we're going to exchange the x and y around. So x equals 4 over 5y plus 2. Now, when we go through the process of making y the subject, what's going to happen is we're going to get the inverse. Okay, so when we make y the subject, that will be, we'll be doing the reverse operations on what was done to y for the original function to take place, which will therefore cause us to have the inverse function. So we can solve this in actually two different ways. What we can do is, one way we can do this is to give the answer as one fraction, which is normally better. So I'll do that way first. So you're going to multiply x by 5y plus 2. So get rid of the fraction. And then you can expand the bracket. So you have 5xy plus 2x equals 4. That kind of frees the 5y from this, or the y term from this bracket. Then we can subtract 2x from both sides. So you have 4 minus 2x. And then we can divide both sides by 5x to leave y as our subject. So 4 minus 2x over 5. So that's one way of writing the inverse function. Is for g. It's called g of x, not f of x, right? G of x, yes. I wrote f there. It's supposed to be g. So the inverse of g is 4 minus 2x over 5. Alternatively, at this stage, we could have done something else. We could have multiplied by 5y plus 2 and then divided by x, which would have left us with 5y plus 2 equals 4 over x. And then we could have subtracted 2 from both sides, so 5y equals 4 over x minus 2. And we can divide both sides by 5, so 4 over 5x minus 2/5. So this is an alternative way of writing the inverse function. It's like as two separate fractions, which actually is useful if you wanted to sketch it, because this can be seen as a transformation of 1 over x. Okay, so that's easy for us to sketch. So sorry, that should say 5x here. My bad, that should say 5x. That's, somebody might have noticed that already and sent a comment on the screen on the comment section already, but I spotted it, which was good. I spotted it before it got too late. So be careful about silly mistakes like that. So 4 minus 2x over 5x, and here you have 4 over 5x minus 2 over 5. They're both the same. If I add these two fractions together, I'll get this. If I separate these two, this one fraction into two parts, I'll get that. It's no problem. You can write it in either way. Both of them are perfectly good. It's normally nicer to write them as one fraction, but if you want to sketch it, separate fractions would be easier for you to see how that would look. Here we're not asked to sketch it, but we're asked to find the domain of the inverse of g of x. So we could do a sketch with that if we wanted to do that, but what would be better for us is to think about the sketch of the original function, which we already sketched in the last page. Okay, but I'll just do it quickly again, just to, we had our y-axis and our x-axis. We had an asymptote, if you remember, when x equals minus 2/5, which was somewhere over here. That's the value of x that the denominator can't be. All right, otherwise it will cause it to be. X can't go as minus 2/5 in here, otherwise it could be 0. And we said the other asymptote is when y equals 0, which is the x-axis. Okay, and we mentioned that this is y equals 0. This is the y-axis. We mentioned it passes through the y-axis at 2. All right, and it looks something like this. If we draw it unrestricted, it looks like this. Okay, that's how it would look. That would be 2. And we mentioned that it's restricted for x values which are greater than or equal to 0. So we're going to start from here, and we're only going to consider this part of it. Okay, the rest of it has to go because that's its domain. So this is not part of its domain, nor is this. So we can see that the range of the original function is between 0 and 2. So the range of g of x is between 0 and 2. Okay, as we talked about earlier, we already found that earlier. It's just done it again. We're wasting a bit of time, but no problem. So the range of the original function is between 0 and 2. And what we want to find the domain of the inverse function. So what we should know is that the domain of the inverse is the same as the range of the original, and vice versa. That's very important for us to know. So the domain of inverse of g of x is the range of g of x. Okay, so we know that the range of g of x is y values between 0 and 2. Okay, therefore the domain of g of x is x values between 0 and 2. Because remember, the domain is always x and the range is always y. Don't mix them up. So that is the domain of our inverse function. Values of x between 0 and 2. The domain of the inverse is the same as the range of the original. Okay, so there's the answer to part 2 of question number 8. And that completes this question. I know I spent a long time on this question, about half an hour, but it's because I want people to understand this, especially this part of the topic to do with domain and range of composite and inverse functions. It's something many students have issues with. So, sometimes you don't get enough time in class to discuss these issues properly with the, tight schedule we have for the syllabus. So I wanted to make sure that you understood that. So this would be like one of those videos where you go to get that kind of explanation, hopefully. I hope that was clear and you understood everything well. Thank you for watching. Other questions that are from this particular past paper can be found in the playlist that will appear over here. Other questions that are from the book, chapter 2 on functions, the Pemberton book, you can find the answers to them over there. Questions that have been asked only, not all of the questions, of course. Questions that students ask me that I think are worthy of a video to answer. Other questions from functions in general from P1 of Cambridge can be found. P1 functions of Cambridge can be found in this playlist over here. And you can subscribe to my channel by clicking on the link over here. If you are interested in other examining boards like Edexcel or IGCSE, you can watch the video that has been linked on the cards during this video, and that will tell you how to use my channel or how to find what you need from my channel efficiently. Thank you for watching and see you soon.